Welcome to the L03 Logic Gates lecture video. Digital logic is based on two voltages. Logic level 1 would be 5 volts. So if I was to put this switch to 5 volts on top of the battery, it would be 5 volts out, logic level 1, or true or high. If I tie the switch to ground, that's going to be a logic level 0, or low, or false. In the transistor to transistor logic, basically there are transistors in there. This is an oversimplified diagram, but we're using transistors switches. So if our transistor is off, we have a direct connection to 5 volts, logic level 1. If we have the transistor on, which means closed, we're going to get a direct connection to ground, or logic level 0. So being that we have 0 volts and 5 volts, we could drive LEDs and other things because we have two different clear voltage. Here we have the partial table of basic logic gates. The first one is an AND gate. It's got the squared in here. We have two inputs and an output. And if we try to simplify this, we use the unique condition 1, 1 equals 1. So true, true, output true. Okay, if we just memorize this one, we could forget about the rest of them. So if both these elements aren't high, then it's going to be low. Here's our OR gate. Our unique condition is 0. 0, 0 equals 0. Okay, then we could go ahead. If it's anything different, it's going to be high, because an OR gate, either of the inputs or both are 1, the output's going to be a 1. We could simplify it by just using 0, 0 equals 0. Okay, the inverter is just going to convert it to the opposite. Okay, here's the other logic gates. We have a NAND gate, which is basically an AND gate, and we put a bubble on it. This means inverted, so it's like putting an inverter on the end of an AND gate. So again, we have our unique conditions. So 1, 1 equals 1, gets inverted, becomes 0. Anything else is a 1. A NOR gate is an OR gate with an inverter on it, a bubble, and its unique condition is 0, 0, 1. So we have 0, 0, it's a 0, inverted, becomes a 1. And we can, anything else is going to be a 0. An exclusive OR is an OR gate which excludes the like pair. Okay, so this is only true or high when both of these, either one of these are active, but not both. And the exclusive NOR is the XOR with an inverter. So anytime that the inputs are opposite, it's going to get inverted back to 0. When we analyze these gates, and we're going to start with the AND gate, what we're going to do is we're going to look at our two inputs. And since our unique condition is 1, 1, we're going to mark on our waveform the two highs and then combine them, and whenever we have the two highs, we're going to put a high output. Okay, here we have our two input AND gate, and we have two waveforms, and what I'm going to do is I'm going to highlight everywhere that it's high. Okay, now that I have both of them marked, we're going to go ahead and change our pointer to a pin, and we're going to take a look. So anywhere that there's two highs, we're going to have a high out. Okay, so here we have two highs, and then we have a high over here, high over here, and it's going to be finish out the law. It's kind of ugly, but you're going to see something really beautiful here in a second. Okay, here's my beautiful CAD diagram, and you can see that high, 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 and everywhere else it's going to be simply 0. Here's our OR gate. So again, our unique condition 0, 0 is 0. So we're going to mark everywhere on our waveform where there's a 0, and where they combine, we're going to put a 0 down. We could go the other way, but it'll be a lot more work and more confusing. Alright, now that we're going to do our OR gate, we're going to highlight wherever it's 0. Whoops. Okay, now we're going to change pin colors, and we're going to figure out where they to match. Okay, so we have, 0, 0 equals 0. So there's 0 here. 0, 0 starts here and ends here. Keep in mind, you're not going to have these cheat lines. You're going to have to put those in yourself. And I think I have it. Here we have the CAD answer, and it appears that we did well. We got all our 0, 0s lined up.